Now let's proceed to question number 28. Here, this question has two choices. In the first choice, it has been stated using integration, find the area of triangle ABC whose vertices are A, B and C, where coordinates of A, B and C are 2, 5, 4, 7, 6, 2 respectively. And in the second choice, it has been stated find the area of region lying about x-axis and the included between the circle having the equation x square plus y square equal to 8x and inside of the parabola having the equation y square equal to 4x. So let's start with the first choice. As here we are talking about area of a triangle bounded by 3 points. Very first, let's plot these points in the Cartesian plane. You can observe I have here point A, B and C. I can easily obtain area of the region bounded by this triangle if I obtain the equation of AB, BC and AC. So very first, let's obtain the equation of AB considering these 2 points A and B lying on this line. So I get here equation of the line AB given by y minus 5 equal to 7 minus 5 upon 4 minus 2 into x minus 2. And when you simplify this, here you get the required equation as y equal to x plus 3. Next, in similar manner, I can obtain the equation of the line BC, which is y minus 7 equal to 2 minus 7 upon 6 minus 4 whole into x minus 4. When you simplify this, you obtain the equation y equal to minus 5x upon 2 plus 17. And in similar manner, let's obtain here the equation of line CA or AC, which is given by y minus 5 equal to 2 minus 5 upon 6 minus 2 whole into x minus 2. So here this simplifies to the value y equal to minus 3 upon 4x plus 13 upon 2. So here you can observe this is equation of the line AB, this is equation of the line BC and this is equation of the line AC. So these are the required equation of the 3 lines. When you write these 3 equations here, you can observe as I need to figure out the area of the triangle ABC. How that could be obtained? I can obtain integral of y, that is integral of x plus 3 from 2 to 4. That will give me this region. Here you need to take definite integral to obtain this area bounded by this straight line and limits will be from 2 to 4. Next, I will be obtaining this region where I will be taking up this straight line BC where I will be taking integral of minus 5 by 2 x plus 17 where limits will be from 4 to 6. And to obtain area of the triangle ABC, I need to subtract the remaining region and that will give me the required area. For subtracting the remaining region, here the area of remaining region will be integral from 2 to 6 of minus 3 upon 4x plus 13 upon 2. Let's take that into consideration and get the required area. Here, as I have to obtain area of triangle ABC, so you can observe in this case I have integral from 2 to 4 for x plus 3, this is line AB, this is for line BC minus this is the region by line AC. So when you simplify this, integration of x plus 3 will be x square upon 2 plus 3x. Next, integral of minus 5x upon 2 will be equal to minus 5x square upon 4 plus 17x, and for this integration will be minus 3x square upon 8 plus 13x upon 2. So when I simplify this, here I get this value where in this case limit is from 2 to 4, here it is 4 to 6 and here it is 2 to 6. And I have taken up minus common from both of these which gives me a plus sign here. And when you substitute these limits here, you will obtain here 8 plus 12 minus 2 minus 6, here minus 45 plus 102 plus 20 minus 68 and here 27 upon 2 minus 39 minus 3 upon 2 plus 13. So here I have put the limit, upper limit 4, here lower limit is 2 in this case, upper limit 6, lower limit is 4. In this case, upper limit is 6 and lower limit is 2. When you simplify this whole, you obtain the required area equal to 7 square units. So you can see in this way we have obtained the required answer. This is the area of the triangle ABC, 7 square units. And this is a 6-marker question. In this question, when you obtain these 3 equations, that is the equation of line AB, BC and AC, you will obtain complete 1 mark for these equations. Next, when you consider this graph, for this graph where you are plotting these lines and plotting the points, you will obtain another 1 mark. And when you find the integral in this step for obtaining this equation, you obtain here 1 mark for this step. For finding the correct integration, you obtain 1 mark. And next, for finding and solving the correct value after putting the limits, you get 2 marks. So there you get total 6 marks for this question. I hope it is clear to you. Now let's move on to the second choice of this question. It states that find the area of the region lying about x-axis included between the circle x square plus y square equal to 8x and inside of the parabola, which is y square equal to 4x. So let's proceed with this. Here we are talking about a circle. You can see here this is the circle, and here when we consider this equation x square plus y square equal to 8x, you can calculate and find that here the center will be 4, 0. If you represent this circle in the standard form, you will obtain the center is 4, 0 and radius is 4. So here this is 0, 0, this is 4, 0, the center of this circle. When I consider this parabola y square equal to 4x, let this be equation number 2. You can observe this parabola is touching the circle at the point 0, 0, that is origin. It is intersecting this circle at another 2 points. So let's solve these two equations to obtain that point of intersection. For that, I'll be using up this equation number 2 and I can substitute y square equal to 4x in equation number 1. So on doing so, you obtain here two possible values of x, that is 0, 4. If you substitute 0, 4 in equation number 2, you will obtain the corresponding value of y, and that will help you out to obtain the intersection point 0, 0, which is already obtained as origin. The next is 4, 4 and 4, minus 4. So when we plot these points here, this is the point 4, 4 and this is the point 4, minus 4. So here you can see that this parabola is intersecting at this point, and when we are talking about the required area, here the required area includes the area lying above the x-axis and included between, or you can say included between the parabola and the circle. So what is the area included between parabola and circle? That is this region. Now your task is to obtain this required area. How you can get that? Very first, I will be considering this equation of the parabola. Here in this case, I can see that y can be considered equal to 2 root x using the equation of the parabola. So here, if I find the integral of this from 0 to 4, that will give me the first half of this region. After that, I will be taking the equation of the circle where y is equal to square root of 8x minus x square, where I can take up the limit from 4 to 8. Now on solving this, you will be obtaining the required area. So we will be taking up these two. So I can write over here that this is integral of 2 root x, where the limits are from 0 to 4, plus integral limits defined from 4 to 8 of square root of 8x minus x square. So this is the required area bounded by the three curves, that is x-axis, the circle and the parabola. Let's apply integration here and get the required value. So on integrating this, you will obtain 2 into 2 upon 3 x raised to the power 3 by 2, where the limits are 0 to 4, and here on integrating this, you obtain half of x minus 4 into square root of 8x minus x square plus 16 times sine inverse x minus 4 upon 4, where the limits are from 4 to 8. So on substituting these limits, you get here 4 upon 3, 8 minus 0, while you get here half of 16 pi by 2. You can see when you substitute 4 here, if you have 4 raised to the power 3 by 2, you will be getting 2 cube, that is 8, and you have here 8 into 4 by 3. In this case, when you substitute 0, this whole term becomes 0. Coming to this part, when you substitute 8 over here, this will become 0, and when you substitute 8 here, this will become sine inverse 1, that is giving you 16 pi by 2. So in similar manner, when we simplify this whole part, I will be obtaining here 32 upon 3 plus 4 pi square units. So this is the required area bounded between the circle, the parabola and the x-axis. So this was a 6-marker question. Here, when you obtain the required points of intersection, you will obtain 1 mark till this step for obtaining the correct point of intersection of parabola and the circle. Next, for obtaining the correct graph, you will be obtaining 1 mark till this step. After that, when you obtain the correct equation for this integral, here you will be obtaining 1 mark. For finding the correct integration, you will obtain another 1 mark, and for final answer, you will obtain 2 marks. That gives you total 6 marks for this question. So in this way, we can solve these types of questions related to area. I hope it is clear to you. Let's proceed to our next question.